Howdy folks, this is Sean. Welcome back to the shop. What do we have on the bench here today? This is, I call it, the KJ4PTD SnapStack Yagi. What's that mean? Well, KJ4PTD happens to be my call sign, and these happen to be SnapStacks. They are, well, this is a SnapStack. It is designed by CommScope. Andrew Systems came up with this, not CommScope. CommScope bought Andrew. Doesn't matter. I digress. It was invented by Andrew Systems. It's a cable hanger. This one is specifically sized for 1/2-inch cable. They go up to, SnapStack goes up to 1 5/8. Cable keeps going past that. Next size up would be 2 1/4. SnapStacks stop at 1 5/8 diameter coax. This is the smallest that SnapStacks go, which is 1/2 inch. This is a rubber grommet that is made to go to 3/8 inch diameter cable and is designed specifically to fit into a SnapStack hanger. As the name would imply, they snap, as you can hear, and they stack on top of each other. On a tower application in 1/2 inch, these are designed, now whether the carrier will let you do it or not, that's a whole other story, but these are designed to go 3 deep for 1/2 inch, 3 deep for 7/8, and 2 deep for 1 5/8. But I have a ton of these lying around because my that's the industry I work in, is the wireless industry. Climbed towers for over 13 years. I currently work doing DAS, distributed antennas, and structured cabling type work. But just you can't climb forever. But this is an antenna, a 2 meter, 140 megahertz amateur band Yagi antenna that I have designed and built myself for use here at my house on my own personal 70-foot Roam 25G tower that is right over that way, sitting in front of my house. I'll shoot a video of it sometime, introducing you guys to my tower and showing you that. It'll probably be when I go to put this back up. I designed this and put it up originally on my tower on a rotator, and I put it up with horizontal polarization, and that was really fun for listening, but it's really not practical for what I'm wanting to do with it, and that's, you know, to check into distant nets and distant repeaters and do FM simplex on 2 meter with it horizontally polarized. That's more for doing sideband, which is great. I don't have a 2 meter sideband radio, so there's really nothing for me to use it on. It received like gangbusters. I could receive and work the repeaters, almost any repeater that I could work simplex. I could still work on this even though we had cross polarization, simply because the gain on this is still good enough that even with the polarization being 90 degrees off, the gain was still made it, it still had enough gain at 90 degrees off that it equaled a dipole. Anyhow, it still worked. But I'm going to be taking it apart here so you can see how it works. I've got 2 holes here that line up to these 2 holes in a crossover plate. What am I crushing over there? Oops. That line up to these 2 holes in this crossover plate, and they get bolted together through there with flat washers on either side. There's enough play in these that the plane might not be true, and what you do for that, let's see if I have a piece here. This should work. what you do for that is you will clamp, once you get that bolted through there, you will clamp with a couple C-clamps or vice grips, clamp another straight edge across the top of these as you snug all of this up, and that will guarantee that this is perfectly in alignment. This angle is 2 inch, no, inch and a half by inch and a half by 1/8 by 1/8 inch thick. So inch and a half by inch and a half by 1/8. You can get thinner aluminum. This right here is inch and a half by inch and a half, but yeah, that's a 1/16. Actually, that looks under a 1/16, but I'm sure it's sold as 1/16. You want to get the 1/8 inch if you're going to be using these SnapStacks, because how the gap between here and here needs to be, that's designed to go into a 5/8 diameter hole in 1/8 inch thick steel on a tower. It's a standard size hole for securing cables. It's waveguide ladder. Waveguide being the cable itself. The ladder supports the cable. Waveguide ladder has usually a 5/8 hole, and then a 1/2 inch hole, then a 5/8 hole, then a 1/2 inch hole. 1/2 inch hole being for butterfly hangers, and then the 5/8 hole being for your SnapStacks. So that's what I've done here. I've drilled, watch me be wrong now, that's 3/4. Yeah, I'm measuring that at 3/4. I'm pretty sure these are supposed to go in a 5/8 hole. I'm measuring this at 3/4. I may have drilled these over to make it a little easier to install. SnapStacks are not the easiest thing to do, especially when they have grommets in them. I'm taking them out easily here because I've done millions of these in my life. Anybody that has ever dealt with these knows that they're not that easy. But just to demonstrate, so it goes into the hole like that, and the rubber bushing will isolate your your reflecting elements. So here are the elements for the Yagi. They are soft copper tubing, 3/8 inch outer diameter soft copper tubing. That is key, because I don't remember, I've got it written down. The calculator that I used for this antenna takes everything into account that I needed to take into account. So the outside diameter of my elements, the fact that they are insulated. So they are insulated, but they are also through a conducting material. So what is supporting them is conducting material. As you can see, the SnapStack is the same width as the beam, so it's 1.5 inches width. So this is no different than having an insulator holding your element in the middle of a square sectional aluminum beam. So if your beam was a not just an angle, but was a full square, this electrically, this looks like a full boxed beam, and it's because it's canceling out the portion in the middle of that. So, but that's how they go together. You saw that you can stack all of these together whenever you take it apart. Everything's fit right here on the bench. Obviously, a few things went over the edge. Let's see. This is the longest piece. This piece of the beam right here, which is the forward portion of the antenna. That is the longest piece. So that means this, our smallest element, would go in this first hole here. You can see tarnish, but I also have the centers marked. So you would simply, you can just pop these over it, but I'm going to push them in from the side because snapping it over it could, again, this is soft copper tubing. It's pretty easy to bend. Your best bet whenever you get this, so whenever you get this tubing, it will come as a spool. What you need to do is take one end of it and secure it. So unroll it loosely, or as best you can, but don't worry about getting it too straight. And secure one end to a trunk of a tree, the bumper of your truck, something. And then get the other end, and you'll probably have to use vice grips to secure it on that end, and grab the other end with a pair of channel locks and pull as hard as you can. And pull it, and you will stretch it just ever so slightly, but it will pull it perfectly straight. And from that point, you have to be careful not to bend it, because it bends really easy. Once you get it cut to length, you can take this and roll the elements on a flat surface. For instance, ooh, loud noises. This aluminum plate right here. Set this out of the way. So, just like you're making a Play-Doh snake, but it'll do the same thing by rolling this on a hard flat surface. We'll straighten these back out. Straighten them back out good enough to work in this antenna. The one you really do have to watch out for is your radiating element, and there's our little gamma match on it. Because this, obviously, I can't roll it like Play-Doh to straighten it back out. To make these bends, so the calculator I use also tells me, you see my old Sharpie marks here for the very center, the center of bend. So there we go. Center of bend, and then beginning and end. Beginning and end of bend, and very center there. And so I've got all of those measurements were given to me in the software. What I did to form this bend, let's see, I've got to have one here. This is a bit of an extreme example. Roll of electrical tape, and I simply, this might not be economical for you. I have an abundant supply of electrical tape. This one's about right. So electrical tape, this roll's been used. Normally it'll be slightly bigger than that, but you can see that fits in there. That would be about perfect. But take a new roll of electrical tape and waste the tape until you get the diameter that you need. This diameter is specified. The batteries in this are dead, so I can't tell you. Great tool, right? What is that? It's 3 inches. So this is a 3-inch bend. So get a piece of roll of electrical tape, 3 inches, and then clamp this down to the edge of your bench and use it as a bending mandrel to bend your radiating element around. We'll open this up here in a minute. So what else? SnapStacks, how to easily install them. So yeah, be careful installing these. This is our next element. You can just push them on, but be careful. You don't want to bend your elements, because they bend relatively easily. Alright, so this is our shortest element. It would go on the very front. There are 2 recesses right here in the rubber grommet, and the spine goes in the center of these two little tabs inside the SnapStack. When you look through the back hole, that spine should be facing straight up, and the slit should be pointing down the way. Whenever I squeeze this, there are two little ticks right there that get caught by these two tabs there, and that will hold it in. You will want to start one side of your snap in the hole, and then press the other side and rock it in. That is the motion for putting a snap in. I know it sounds basic. But that is not the easiest thing for some people to get. And until you've done a few of them, you might just, you're just not going to get it. So, but they are very secure, and that element's in there. There is adjustment and play. Really what you're going to have to do once you get this mounted on the tower, you're going to have to climb down 15 foot and take a look up at it, and then climb up and tweak one element at a time to get them set right. But once they're set, they're not going to move. Birds come and land on it all the time. They're not going to knock it out of alignment. Once you have it set, you're fine. So, and then to remove them, obviously the opposite of installation. What I tend to do is make a hook and just use these two fingers and push in right here and then rock backwards. So push in and then rock backwards. Take them out. Again, I know it sounds basic explaining how to install these, but they are surprisingly difficult for some people. And you'll notice that I do have an extra snap in here. That is handy for a number of reasons. This last snap in will not hold a grommet unless it has something to snap into. This snap in is for this piece right here. It's a trapezoid standoff, or three-way standoff. It is a piece of support hardware for towers. This is that standard size hole, and it's stamped in really thin sheet metal, but again, you can see that they have stamped that depth in there that is designed for snap-ins. The snap-in's expecting that depth. Again, that's why you have to use the 1/8 inch thick aluminum, and you don't want to use the 1/16 inch thick aluminum, is so that the snap-ins will snap into it securely. But that last snap-in I use right here to support my coax coming onto the beam. You can see I've got two holes drilled right here. They are slightly askew. They are supposed to be, because I drilled my holes in the bottom of my matching box here. I drilled those slightly off as well, but those holes line up with these holes, and what I have to do, I have to this isn't the best design, but it worked, and it was pretty seamless, is I take this back cover off, and I bolt the back cover to the beam, and then I screw with these 4 Phillips head screws. I screw the radiating element back on, and now it is mounted. That's that. Actually, it mounts this way. I've got a line here that tells me where the radiator goes. It mounts like that. And there is another element right here. It goes in the middle of this loop of coax. That is fine. It doesn't see that at all. That's just the gamma match. seeing how I want my coax to go back here, so this is the portion that mounts to your mast, your rotating mast. I use two back-to-back 90 in male to in female adapters and screw that into the back here, and that sends my signal back forward. And that also allows me to dip it down below the plane of this aluminum angle and below the plane of the box, so that I can hook my coax up to it and then tuck it and run it under this channel and then down the mast. So what I need to do, all I need to do, I need to turn this I don't want it drinking water. Drinking water is the way an angle sits on a tower. So if you can put a piece of angle on a tower like this or like this, you will always want to put the angle on the tower like this. And it's because sitting like this is a corner that can catch water. Even if this is 90, this corner will still catch water. And anywhere that you're holding water is a place for oxidation to occur. I know this is aluminum. Aluminum still oxidizes. It still not rusts, but you know. But you want to put it up like this. So this is how it sits up there right now. Again, not holding water, or drinking water is what we call it. So I want to turn it like this. And that'll work fine with my crossover plate because these holes are uniform. So all I have to do is transfer these holes here to this side here and bolt this to this side and vice versa with this one and bolt it over here. And that will change the polarization of my antenna. I'm not going to do that right now because that's pretty easy and pretty obvious. And I'm going to open this up and we'll take a look inside of it. Now, this silver box is a polyphaser surge arrestor. Hold on.
You're a surge arrestor.
No, this is a polyphaser surge arrestor. Or it used to be a polyphaser surge arrestor.
You're recording.
I am. These are actually polyphaser surge arrestors.
Oh, it's chilly in here.
Yeah, it's because it's really warm in here.
When the sink runs out, I have this much before I have to go to the store.
Yes. No, you.
Oh, you do.
And we're back. I was saying that this silver box is a polyphaser surge arrestor. These are actually, well, this isn't anymore. Hold on. What? Okay. And we're back. I was saying that this silver box here was a polyphaser surge arrestor. It is not anymore technically. Neither is this. This is a polyphaser surge arrestor. We'll go ahead and open it up and take a look inside. It has a warning here. Do not remove lid. Danger! Danger! Do not remove lid. Now, if this was powered up, yeah, you wouldn't want to remove the lid with this passing any major amount of RF, just because you would have a decent amount of RF exposure yourself. And if you touched anything, you'd get a pretty wicked burn. So all of this, again, so the SnapStacks I have access to. The aluminum was spare, it was scrap aluminum from building some stiffeners, some antenna stiffeners for some old, they're Amphenol LPA antennas. They're a big, huge, deep log periodic LPA, log periodic antenna. Amphenol LPA log periodic antennas, they look like a big, huge cheese wedge up on the tower, and they caught the wind, and they moved around a lot, so we had to build stiffeners, and so this angle was some left over from some of that. This plate right here is this plate right here. This is 19 inches wide by 4 U's deep. U is a rack measurement, a unit, one rack unit. So this would bolt into a 19-inch equipment rack, and it's just a nice thick aluminum plate that had some equipment mounted on it hanging in a rack that I decommissioned a long time ago. I have a bunch of these plates sitting around, and they're perfect for chopping up into crossover plates. In fact, one of these holes is one of these holes that are in the plate. I lined it up so that I could use one of them, and you would never know. And then this box is polyphasers that I harvested years ago. The only thing I had to purchase for this was the 3/8 OD soft copper tubing from Lowe's. I did have to buy 2 rolls of it. I don't remember what the length was. I think they were 25-foot rolls, so I wound up buying 50-foot. I think that's about right. Anyhow, it was about $45–50 in copper. You don't realize how expensive copper is until you're paying for it. And then you're like, wow, that's expensive stuff. So that's the inside of a polyphaser. That's a little sad that that's it. Super high farad ceramic cap, a really thick inductor, and then just 2 tuned, and that's what does the surge suppression right there. And then just 2 tuned and they weren't even aligned very well. I guess they didn't have to be, or maybe that was part of the tuning. Maybe they run power through it and somebody just sits there and knows how to bend these out of alignment just to get the correct, because this does have a specified attenuation on the signal, and it's tuned very specifically 800 to 900 megahertz and for 750 watts. So, and it has a stamp right here when it was tuned, tuned for PCS, and it's stamped in there. That can't be PCS because that's not the PCS band. Yeah, that must just be the initials of the person that was doing it. You can also see stamped here in the Come on. Down. Come on. Whoop, too much. Steady. Hey, would you look at that? Alright, welcome back. I have no clue where you left off. We were talking about this and that, and I made a few jokes. You laughed. We had a great time. We even had company. We had guests in the shop, and I shown you my little secret stash where I keep my hardware. That was a very intimate moment that I shared with you there. I don't know if you got that or not. I hope you did. Anyhow, we were working inside of here. I was taking stuff apart. I was looking for some cutting devices. I still never found those screwdrivers I was looking for. That might have been when I lost you. I was looking for screwdrivers. There they are. Woohoo! So, that's what happened. I don't know what part of that you were part of. Oh heck, I'll show you the box again. If you saw it already, and you didn't take the time to pause or rewind, but you know you got a cheap thrill out of seeing it. I will show you my box again. Actually, no, I won't. Not just yet. Let's build the suspense, because I have 4 more screws, and I was about to do a bad thing. I was about to give away the screws that I needed to keep. You go around just handing screws out, and they're the ones that you needed. We'll rip that piece of Teflon off because we don't need that. We'll leave that on there for now. We might solder to that later. I don't know if I did in here or not. I know I don't need this plate. And see, I don't know why I'm taking this apart, because I'm not building another one yet, but I'm already this close. Just 2 more screws at this point, and I've already tempted you with a potential second glimpse at my box. If I, depending on when the camera cut out, this might be your first glimpse at my box, in which you will want to have your finger ready over that pause button. All right, we'll keep these screws because they screw the back on, but these screws, what I do when I have things like this is we put them in the box, and then we give them a good shake. Put the fingers in the box and pull out all kinds of fun doodads. Here you go. I don't know if y'all get your meters locked up like we do, but they like to put tamper evidence seals on everything here in America, so having a spare tamper evidence seal that hasn't been sealed yet in your box is quite a good thing. A little spirit level, because why not? Some spring-a-things. 20 amp fuse, 30 amp fuse, 3-pole power connector, little piece of tubing, just all kinds of, and screws galore, just a 380 ACP, 22 rimfire, all kinds of great fun things in here. Fun little box. Alright, we'll throw that in the trash box as well. We'll put this back together for now and put these aside. So you got to see what was inside of a tuned polyphaser. Now wideband polyphasers are completely different, and then bias injection polyphasers are completely different. So you can't judge one from seeing the inside of, you can't judge them all from seeing the inside of one. But this is a little surprising when you see inside of it and how basic they are. I think maybe that's why it's danger. Do not remove the lid, because they don't want you to see what you pay all the money for, because this was a very expensive component back in the day. And that's it. That's all you're paying for. There's nothing there. So we'll put these back out the way, and we'll open up this KJ4PTD SnapStack Yagi Gamma Match box and see how horrible this is. So everybody understands some of the stuff we do really, really well, and then some of the stuff we do, especially when you're putting a cover on it and you don't think you're ever going to be taking the cover off for the first time in front of the camera for YouTube, not remembering what the inside looks like, and it's not too bad. So these rubber grommets on the side, again, it's this same rubber grommet, and I've simply sliced it, and I've drilled 2 holes into the side of the box. So I've drilled a hole here and here, and then fit that grommet into that hole, and that holds the end of my hairpin radiating element. Here, I don't know if you can see, it's a little piece of Teflon tubing. Let me see if I can tilt my light up. It's a little piece of Teflon tubing right here, and I don't know if this is going to focus on it. A little piece of Teflon tubing right here that is cut to sandwich the exact width between these rubber grommets. What that's doing, it's keeping this safe and isolated. If you can see the end of my elements here, that they have grooves cut in them, 2 grooves. What that does is it gives me a thermally isolated portion of the tubing that I can get hot enough to solder to. So you cut yourself 2 grooves, and the piece between that groove, that tongue that you've left, you can get that hot enough to solder to. So cut those grooves, clean it up really good, and then you can solder on. You see right here where I've connected the center of my center to the center of this. The center from the tail coming back in connects to this side of the hairpin. The center from this side connects to this side of the hairpin. The grounds are all commoned, and it's fed. This is all laid out in the software. This works great, by the way. This whole antenna, I put it together. I set it up on some plastic sawhorses out in my parking lot out here, out in front of the shop, and tested it with an Enritsu S331 E331, an Enritsu line sweep antenna and cable analyzer, and I will impose that test on the screen right now for you to look at. I may have already done it. I probably already have, so you can be looking at it. But it's a beautiful antenna. This isn't the test isn't even up on the tower. This is simply on some plastic sawhorses out, probably 3 foot above asphalt, and just a LMR 240 jumper running to this. That's it. So whenever I go to mount this for horizontal or vertical polarization up on my tower, I'm going to drill myself a couple little holes right here in the bottom of this, so that, actually I'm going to drill them in this side so that my label faces up. I'm going to drill me a couple holes. No water has made it in here, but now that it's going like this, it could, and just by putting a couple little weep holes here in the bottom, I feel pretty confident in putting this up on the tower and changing its polarization. My connector looks good. It's got some oxidation on it. This simply happens to RF. It's going to do that. But that's it. That's the KJ4PTD SnapStack Yagi. I will put some links down in the doobly-doo to the calculator I've used for this. Here's another polyphaser. A little more going on in here. Still another cap, a lot nicer inductor around a ferrite core there, a big huge power resistor, diode, another thick chunky inductor there. This piece of film went against the body right here with a little piece of mica film between it, so that was another capacitance network right there. This grounded to the chassis there. No, actually it went against this piece of film here, and it has its mica on it. So that went down there. That went there. Anyhow, it went in there somehow. It went in there like that. But another polyphaser that is, and this is polyphaser brand 2. I don't know what the frequency of this one was, but just another design. They do get a lot more complicated. But that's it. I was saying something else and got distracted. I'm going to drill some holes in there. I'm going to change the, I'm going to transfer these marks to here. and these marks to here. Drill those holes, and then we're going to put this back up on the tower, and that's it. Oh, that's what I was saying, down in the doobly-doo. Take a look down in the description. I will have the link for the ham whose calculator I use for this. It really is great, and again, there's check boxes in there. If you're doing it like this, that's the keys. This aluminum needs to be 1.5 by 1.5 by 1/8 inch thick aluminum. It's the biggest piece of aluminum you're going to get at the hardware at your local big box hardware store, but they do have it. This pipe is 3/8 outer diameter soft copper tubing, and in the calculator you set the OD of your elements, and you would set this up as 1.5 inch tubular boom, 1.5 inch square tubular boom. I don't remember if it has round and square. I think it actually did have a checkbox for round or square, but this would be 1.5 inch square tubular boom. And that's it. I hope you enjoyed this. Click subscribe, should be down here. Click subscribe. I do all kinds of videos. And I'll be doing one here very soon of putting this, once I get these modifications done, of putting this back up on the tower. And I'll shoot a video up there showing you how I do that. Show you my little gin pole. It's janky. Again, not everything I do is professional. I don't ever claim to be an expert on anything I do. I am definitely not an expert. I'm just a hobbyist, and that's all this is showing you what I do and how I do it. When I show you my tower and my gin pole up on the tower, it's not exactly the best, but I understand loading and to keep my load centered under the pole. Anyhow, you know, this is not a tutorial. This is simply me showing you what and how I do, and giving you some ideas maybe, or jumping off point. But this definitely it is what it is. But I do all kinds of videos, all kinds of little projects and stuff. I have very many interests. So click subscribe. Look down in the description for more information about this and links to other fun things. And as always, this has been KJ4PTD 73. Right. Don't know if that's too tall, too short. That should be good enough for you to see the center here. Ain't too worried about it. That's what I forgot to show you. The back of the crossover plate, so the antenna boom sits across like this. The back side of the crossover plate, I've simply through-bolted 2 pieces of unistrut just far enough apart and just wide enough that I can fit up to a 2.5 inch unistrut strap or pipe, unistrut pipe clamp on here. So you simply buy 2 unistrut straps that match the diameter of your mast and bolt it up. So that's a very universal mount right there. That'll go to up to a 2.5 inch mast and down as small as whatever the smallest mast you dare to put it on. Alright, so yeah, just wanted to show you that. I'll probably sneak this in before the end. I might put it after the end. It makes more sense. I've been talking like I'm putting it after the end. We'll put this after the end. KJ4PTD 73.